Good afternoon, and how is everyone doing? Okay, today quickly we are going to look at this. This is Mr. jOnZ. Please, you can still follow me and subscribe on my YouTube channel. You can still find me there, following the same name, Mr. jOnZ. Find it on the YouTube channel. You can subscribe and watch more videos. Okay, so today we are going to look at 2020 GCE paper 1. That is science paper 1. This is physics. That's the one we are going to deal with today. And we are going to solve question B7 and B8. These are the ones we are going to solve. So let's start. Okay, so question B7 is saying a step-up transformer, just from this word step-up transformer here. A step-up transformer, it is already telling us to say this kind of a transformer or this type of a transformer, it is unique for that statement already. Step up meaning to the primary core, the number of turns to the primary core are less than the number of turns in the secondary coil. That's why it's called a step up transformer. Okay, so a step up transformer increases the voltage of AC supply from 110, meaning from 110, which is here, 110, from 110 to 220, meaning this is the voltage in the secondary, this is the voltage in the primary. Let me use a special paper for data collection very well to avoid dirty. Okay, so according to the statement, you're saying it is a step up transformer, and then the number of turns in the primary, the voltage in the primary will record, the number of turns in the secondary, and the voltage in the secondary will also record. So from the statement, we've already been told to say the number of turns from this statement here, the number of turns in the primary, the voltage in the primary is already 110. So the voltage in the primary coil is 110 volts, and the voltage in the secondary coil 220 volts. Okay, and then they're saying the primary coil dissipates a power 1.1 kilowatts, and the transformer has the efficiency of 100%. Okay, so from this statement it will help us to solve. So now they are saying this kind of a transformer, it is 100% efficiency, meaning 100% efficiency, meaning the power in the primary is equal to the power in the secondary. So we are going to say the number of turns in the secondary over the number of turns in the primary is equal to the number of turns, the voltage, the voltage in the secondary over the voltage in the primary. These are some of the formulas we use. Now in this case, we are going to say what the number of turns in the secondary. Number of turns in the secondary are the ones we have been asked to solve. Turns in the secondary, they're the ones we've been asked to solve. So here to be x. So here to be x. And then the number of turns in the primary. The number of turns in the primary we've been given from the question to say 400. And then the voltage in the secondary, we have already seen it to be 220, and the voltage in the primary is 110. So here we are going to cross multiplication like this. So we are going to have 400 multiplied by 220, which will give us x multiplied by 110, like this. So from here we'll multiply 4 times 400 times 220, which will be 88,000. 88,000 equals 110x here, meaning we'll divide both sides by 110. Divide both sides by 110. That when we cancel these on the calculator, 8,000 divided by 110, we are going to get our answer. X will be, on the calculator it's giving me 800. That is our answer. So now that 800, it is 800 what? Remember, we are calculating the number of turns in the secondary core. So 800 turns. That is done.